finally, we are checking out the last 5 problems on the MCA packet, 36 through 40, and 36 and 37 refer back to the same scatter plot that 35 was talking about. Alright, so in 35 we said that the correlation between weight and age was positive, or it has a positive slope. So for 36, they're asking us to find the approximate slope for the line of best fit. We can kick out A and B because those are negative slopes, and we already said that it has a positive one. A couple different ways to find the slope here. You can kind of just look at it and see what's happening. It looks like if we're going over about 5 in between 2 points and up close to 5 as well, that would be 5 over 5. That would be a slope of 1. To get that a little bit more accurately, this point right here is close to 0, 1. This point right here is close to 5, 6, as 6 would be probably about right there. Alright, and if we wanted to, we could use the slope formula. So take my y's, so I would say, okay, here's x1 and y1, and here's x2 and y2. Take my 2 y values, 6 minus 1, which is 5, and then go the same direction, 5 minus 0, and I get 5 over 5, which equals 1. So an approximate slope would be a slope of 1. Alright, so we got that figured out. And there's a couple ways to do that, as you can see, rise over run or the slope formula. So I would go with C, a slope of 1. Alright, moving into 37, they're going to ask us to make a prediction based on this data. What is a reasonable weight you would expect to find at age 20? Alright, well, 2 of these weights are too low, A and B. A weight of 6 would be, again, about right here. As we saw, that's about age 5. So that's definitely not it, because 20 is way over here somewhere for age. And a weight of 12 is closer to age 10. So we can eliminate those 2. Now you might be able to eyeball this and figure out, okay, well I'm pretty sure it's this this is the best guess, and that's good, but you always want to be able to check too to see if you have the most accurate answer. So my suggestion is, we know the slope of this line approximately. Let's find a point that's on this line, and let's use a really easy point. For instance, 0, 1. We know that that's close to 0, 1. You could use the point 5, 6 as well if you wanted to. Alright, but I'm going to use 0, 1. And we're going to use that with our slope to come up with an equation using point slope form. So the point 0, 1, and we know the slope is 1, or approximately 1. So point slope form says y minus y1 equals m times x minus x1, and we just fill in. So here's my x1, here's my y1, and I'll say y minus 1 equals my slope, which is 1, times x minus 0 for my x1, my specific x. Alright, I could distribute here. Not much is going to happen. When you multiply by 1, you get the same thing, but 1 times 0 leaves us with nothing. So I will say we have 1x over here and y minus 1. And to solve for y, to put it into slope-intercept form, I'm going to add 1 to both sides. So y equals 1x plus 1. And in order to make our prediction then, so this line right here represents the line of best fit. It's the pattern of our data. I'm going to put this in for the input, or for x. So I'm going to put 20 in for x, and I get 1 times 20, which is 20, and then 20 plus 1 leaves us at 21. So there we go. That is how you get the most accurate prediction, even though you may have already guessed that that was the best one. Alright, lastly, we have another scatter plot to use for the last 3 questions. Changing concentration. Looks like we've got temperature on the x-axis, and we've got concentration on the y-axis, and it appears that as temperature increases, so does the concentration. So for 38, they're asking us to figure out the slope or the correlation. Oh yeah, no, well, they go hand in hand, but positive slope, and it's a positive correlation. As one increases, so does the other. So that also goes the other way. If one decreases while the other decreases, that's also positive. The only time you get a negative correlation is if they're going opposite directions. As one increases and then the other decreases. That would be a negative correlation. Anyway, 39, what is the approximate slope? Oh, also with that, it would slope downward. You'd see a negative slope from left to right. So anyway, okay. 39, what is the approximate slope for a line of best fit for this data? Alright, we can eliminate A and B. Those are both negative. But we can see here, just looking at some points, this is the point 110, or sorry, 10, 1. And then this one right here is about 20 and 2. And if you did that same kind of slope formula, I'd take my two y's and subtract those, put those up top, and my two x's, and do this, and we get 1 over 10. And it's kind of easy to see even if you draw in between those 2 points, right here and right here. This is over 10 and up 1 about. So 1/10 rise over run would work too for our slope. So I would say C, positive 1/10. Alright, so let's check out number 40. They're going to ask us to make one more prediction and then we're done. So based on this data, what is the level of concentration you'd expect to find for a temperature of 70? Let's first look at where 70 would be. Alright, somewhere over here. Do that. Okay, about right there. It appears that every time we go to like 10, we're getting a 1. 20, we're getting 2. 30 would be close to a concentration of 3. 40, close to a concentration of 4. So you can probably make a pretty close prediction just based off of that. But let's just make sure that we get the right thing going here. And again, there are some that you can eliminate. I'm just going to take us through how we would do this one more time using point slope form. So this is over 10, up 1, and we have a slope of 1/10. So we're going to use the point 10, 1. And slope of 1/10. So I'm just going to go through the point slope form version one more time. Although you probably already know what the answer is. Alright, so x1, y1, a specific point. So I'm going to go 10, y minus 1 equals my slope, 1/10, times x minus my specific x value. And this actually works out pretty nicely. I'm going to do 1/10 times x. And I'm just going to keep that as 1/10 x. And 1/10 of 10, well that's nice. That's 1. And y minus 1 over here. So real quick, just solve for y, put it into point slope, or slope intercept form. -1 plus 1 cancels. We're left with y equals 1/10 x. So then we take our prediction, or what we want to find out, 70 for an input. Well, 70 times 1/10 is 7. Alright? And it would have been easy to eliminate a bunch of these. And 7 really is the only logical choice there. But it is always good to check. So there we go. That is the MCA packet